Hi, welcome everyone for a class on transportation problem. We are discussing, in fact, I want the commencement of a discussion on how to obtain optimum solution for a transportation problem. The method what I would like to discuss is known as MODI, MODI. It is not the name of a person. It is called as a modified distribution method. The features of this method are, it is basically an iterative method just like simplex. It starts with a feasible solution. Then a test, optimality test is carried out on this solution. If it is optimum, that is the end of it. If it is not optimum, then the present feasible solution is modified and a new feasible solution is obtained. Definitely that will be better than the previous solution. And like this, iteratively, we reach the optimum solution. So for this kind of iterative procedures, the starting solution is very important. If our starting solution is very close to optimum solution, then in very few iterations, in less iterations, we reach the optimum solution. If our starting solution is hopelessly bad, then we take lot of iterations and of course lot of time to reach the optimum solution. So therefore, starting solution has a very significant role. There are so many methods of getting the starting feasible solution, but we are going to discuss three among them. One is what is called as northwest corner method. The second one is least cost entry method, and the third one what is called as Patil's approximation method. So before I go to that, I have made a broad procedure of the method what I intend to discuss. The first two, these two will tell us where exactly we are starting. If the transportation problem is in a description form, then we are here. Then make it a tabular form, formulate it and get the tabular form. And check whether the transportation problem satisfies the features of our standard form. So I have identified four features for our standard form. So one is minimization, it is balanced, and all CIJs, unit transportation costs, are known, and no preferential transportation. So such a transportation problem, I call it as our standard form, and check it. If it is yes, fine, go in this path. If it is no, then convert it into our standard form and then come back, and then if we have our standard form, then only think of what is called as a get starting feasible solution. Okay, then let me go to a starting feasible solution, how I can get it. Say starting feasible solution, I would like to start with northwest corner method. Before I start this, so I just tell you what are the features of all these three methods. So all these three methods, they have their own criteria of selecting what is called as the making decision. They select a cell for making decision. So what do I mean by that? Okay, so I have taken a transportation problem, so which has 4 sources and 5 destinations. So these values 40, 30, 20, 10, these we call them as supply capabilities of the 4 sources, and 30, 15, 25, these are the 5 requirements, demands of these 5 destinations. Then these 7, 6, 4, 5, etc., these I call them as the unit transportation costs. So in general, I call these things as CIJs, this as SIs, this as DJs, and these are called as parameters of a problem. They have to be given. And you can always, you can again check before I start for this method. So it is minimization problem. So by default, any transportation problem, it is considered as a minimization problem. Therefore, no need to mention separately a minimization problem. Then you can check this total supply capability. This comes to 100, 40, 30, 20, 10. Similarly, 30, 30, 15, 25. If I add all this, it becomes 100. Therefore, it is balanced. And you can see that all CIJs are also given. And no preferential transportation. We don't have any such statement stating that a minimum of so many units have to be transported from so and so source to so and so destination. Therefore, we don't have any such thing. Therefore, I can say that this is in a standard form, our standard form. Now, therefore, I can think of getting what is called as starting feasible solution. Now all this, okay, so now all these are parameters which are given. Now at this top right corner of each cell, this I call it as a cell, and for this problem I have 20 cells. At the top right corner, I am going to write a value, what is called as Xij, what is x11, x12 here, x13 here, like that. So here x45, I shall be writing what is the value. So they are all the values of the decision variables. So that's what we are going to do it. Find out what are the values of these decision variables. Okay, so among all these, right now I don't know the values of all these things, all these cells. For all these cells, I don't know their Xij. Therefore, I consider all these cells as undecided cells. Now I choose among all these cells a cell which is at the northwest corner. It is quite easy. So you know that this is the north, this is the west, and therefore this corner is the northwest corner, and therefore this is the cell which I can see that this is northwest corner cell right now. Now I have chosen this cell because this is the cell which is at the northwest corner. Okay, now what is the corresponding supply? 40 units. And what is the corresponding demand? 30 units. Therefore, I choose the smaller of the two as X11 for this, and I write down what is called as 30. 30 is X11. This 7 is C11. Now 30 units, this is what I have written. Now, so 30 units, this F1 has already supplied to W1. Therefore, this F1 cannot supply 40 anymore. This 40 minus 30, that is 10 units it can supply. It is ready to supply. This demand of W1 is 30. Now it has already got that much from F1. Therefore, W1 need not get anything. So therefore, the demand of W1 is 0. Therefore, this W1 should not get anything from F2. Therefore, this is 0. That is X21. This also is 0. That is X31. And this also is 0. That is X41. That also is 0. This I say that one cycle is over. Then again I start. Now all these force 1, 1, 2, 1, 3, 1, 4, 1, all these 4 cells are decided cells. Now again, among the undecided cells, which is at the northwest corner, I know that this is the cell. Now choose, decide, this cell is decided to make decision. Again, what is the corresponding supply? 10. What is the corresponding demand? 30. Therefore, I choose 10 here. So again, same procedure. So 10 units it has already supplied, it cannot supply anymore, therefore it becomes 0. And the demand of this was 30, so it has already got 10, therefore its requirement is 20. The supply capability of F1 has been completely exhausted, and therefore this F1 cannot supply anything to W3 and anything to W4 and anything to W5. That means X13 is 0, X14 is 0, X15 is 0. Similarly, now again second cycle is over. Again, among all the undecided cells, choose a cell which is at the northwest corner. That is nothing but this cell. Choose this cell to decide. This is 30, this is 20. Therefore choose the smaller value, that is 20. 30 minus 20 is 10. 20 minus 20 is 0. And the demand of this W2 is completely met. Therefore this value W2 should not get anything from F3 and anything from F4. Therefore these are 0, 0. X3 2 is 0, X4 2 is 0. So again another cycle is over. Now again start among all these cells. This is the cell at the northwest corner. Decide this is 10, this is 15, have 10. So 10 minus 10 is 0, 15 minus 10 is 5. The supply capability of F2 is completely exhausted. Therefore it cannot send anything to W4 and anything to W5. Therefore X24 is 0, X25 is 0. So another cycle is over. So again among these cells, this is the cell which is at the northwest corner now. So again decide this is 20 and this is 5. Therefore this is 5. 20 minus 5 is 15. 5 minus 5 is 0. And therefore this has to be 0. That means X43 is 0. So another cycle is over. Now again among these cells, this is the cell which is at the northwest corner. 15 and 20 have 15. 15 minus 15 is 0. 20 minus 15 is 5. Therefore supply capability of F3 is exhausted. Therefore this has to be 0. X35. So now among these two cells, this is a cell at the northwest corner. Choose this cell, and now it is obvious also for W4 this is the only cell through which its demand has to be met. Therefore it has to be 5. 5 minus 5 0. 10 minus 5 is 5. So now this is the only cell, so this has to get 5. You can see here 5 minus 5 0. 5 minus 5 0. All demands of all 5 warehouses has been met, and supply capabilities of all these 4 have been taken out. The goods from these 4 sources have been taken out to meet all this. So this is the solution. Now I can say X11 is 0, X12 is 10, X13 is 0, X14 is 0, X15 is 0, like that. Okay, this. Now I can easily calculate what is the cost total. This is the plan. This is the plan which has been made to send the goods from these sources to these destinations, and what is the associated cost. This is 7 into 30. So 6 into 10, like that, plus 5 into 20, plus 6 into 10, then 9 into 5, plus 6 into 15, plus 8 into 5, plus 6 into 5. This will give you what is the cost associated with this plan. This is so this method appears to be very simple because we don't have to do anything. We have to simply choose a cell and then go on decide the value of Xij for that cell, and selection of that cell also is very simple, which is it is based on its location, not on the value of what is the transportation cost. Therefore this method is not really a good one, and only when it is forced, we are forced to start with this, then only we are starting. Otherwise we will go for other methods. So let me go for now another method, what is called as a least cost entry method. So as I said, so here also the least cost, that will tell you how to choose a cell. Okay, so choose a cell, then check what is the corresponding supply and demand, then decide what is the Xij value of that cell, and subtract that much from the corresponding supply and demand, and then decide the values of Xij about other cells, either row or column, whichever has become 0. Okay, the same thing I shall do it now. Okay, so now just go through all the Cij values. Cij, this 7, 6, 4, 5, 9, like that. You go through all this and find out what is the least value. So I find that the least value is 4. That is nothing but F1 W3, F1 comma W3. This is the cell which I am choosing for making decision. Okay, the corresponding supply is 40 and the corresponding demand is 15. Therefore, I write 15 here. This is X13 is 15. 15 minus 15 is 0. 40 minus 15 is 25. The demand of W3 is completely met. Therefore, it should not get anything from F2. So, anything from F3 and anything from F4. So, all these 4 cells are decided cells and all other cells are undecided cells. Okay, among all undecided cells, what is the least cost now? 7, 6, 5. So, for 5. Okay, 5. Okay, 5 is the least cost and there are so many 5s. So 1, 2, 3, 4. 4 cells are all ready to are competitors for making decision. Okay, they are all ready. So whenever there is a tie like this, so there are 4 cells like this which are having the same least cost. So the tie has to be broken by randomly choosing anyone. Okay, so I shall choose this cell, that is 1, 4, this cell for making decision. Okay, so 25 and 20, therefore this is 20. 25 minus 20 is 5. 20 minus 20 is 0. The demand of W4 is completely met. Therefore this is 0, this is 0 and this also is 0. So again, among all the undecided cells, there is again the least cost is 5. This 5, there is one more 5 and there is one more 5. Again, I break the tie by randomly choosing anyone, say F2, W2. Okay, what we are getting is only a starting solution. Depending upon which cell you select, your starting solution will be different. It doesn't matter. We are starting with only a feasible solution. So this, for this cell it is 30 and this also is 30 and therefore 30 minus 30 is 0. 30 minus 30 is 0. So we have observed that the supply capability of F2 is over and the demand of W2 is also over simultaneously. Please remember. Therefore, F2 cannot supply anything to W1. F2 cannot supply anything to W5. Therefore, these are zeros. And simultaneously the demand of W2 also is met completely. Therefore this is 0, this also is 0, this also is 0. So now again, among the least, okay, undecided cells, what is the least cost? 7, 9, 6, 5. There is one more 5 and one more 5. So choose any one randomly and suppose I choose this cell, that is F3W5. This is 20, this is 5. I shall choose 5. So 5 minus 5 is 0. 20 minus 5 is 15. This is 5, 0. The demand of W5 is completely met. Therefore, it should not get anything from F1 and it should not get anything from F4. Therefore, these values are also 0. Now in the first row, now I don't have to choose anything least cost because in the first row, this is the only cell. Okay. So F1, W1 has to be 5. Has to be 5 because we have to lift goods from all the whatever is available at F1. Therefore, we have to lift it. 5 minus 5 is 0 and W1, the demand which was 30, now it becomes 25. 30 minus 5, 25. Now in the third row, F3, the supply capability is 15. We have to lift it. Therefore, I write 15 here. 15 minus 15 is 0. 25 minus 15 is 10. Okay, now this is the only cell, so I can see a 10 and this also is 10. Write down 10. 10 minus 10, 0 and 10 minus 10, 0. So the demand of all these warehouses has been met and the goods which were available at F1, F2, F3, F4, factory F1, F2, F3, F4, that also has been met, that has been lifted. That's how. So this is another plan. Please remember what we are getting is only a starting feasible solution. This is not the optimum solution. Therefore, associated with this plan, what is the cost? We can easily calculate like this. Say 7 into 5. okay, plus 4 into 15, plus 5 into 20, plus 5 into 30. You can calculate this, plus 6 into 15, plus 5 into 5, plus 5 into 10. So whatever you get here, this is the cost. Okay, so this method, okay, will takes into account what is the transportation cost. Therefore, definitely in general, this is a better method rather than this. Okay, but we have still another method which is a better method. Okay, probably most of the times we are asked to get this, or even in the absence of any statement from which method you are supposed to start with starting feasible solution and then obtaining the optimum solution. In the absence of any such statement, we always think of what is called as Ogel's approximation method. Okay, so this method and the previous two methods, there is slight difference. In the previous two methods, we just by observation chose a cell for making decision. But here we find out what is called as to decide a cell for making decision. To pick a cell for making decision, we need to compute some things. For every row and every column, we have to compute a value, and which is normally called as a penalty. That is why this method is also called as a penalty method. We calculate penalty. So this penalty calculation is for identifying a cell for making decision. Okay, for the first row. So how to calculate the penalty for every row or any column? Okay, choose two cells, which of course undecided cells. Choose two undecided cells and find having the least transportation cost, and find out the difference between the two. Say for example 7, 6, 4, 5, 9. Okay, the least transportation costs are 4 and 5, and the difference between them is 1. So I write it here. I have made slight extensions for every row and for every column. Please remember, these are supply values, supply capabilities, these are demands. So similarly, for the second row, 8, 5, 6, 7, 8, 5 and 6 least. Therefore, the penalty for this row is 1. So for the third one, 6, 8, 9, 6, 5. 5 is least and the next least is 6. Okay, and the difference is 1. So 5, 7, 7, 8, 6. So 5 is least, 6 is next value. Okay, and the difference is 1. So for column also, it is 7, 8, 6, 5, 5 and 6. It is 1. Okay, so 5, 6, 5, 8, 7, again 5 and 6. It is 1. So 4, 6, 9, 7. 4 and 6, difference is 2. 5, 7, 6, 8, 5 and 6, the difference is 1. 9, 8, 5 and 6, 5 and 6, the difference is 1. So the penalty values of the first cycle we have computed, and so I just put a line like this. So after completion of one cycle, then I shall again calculate the penalty, which I will be writing it here. Okay, before that. Okay, now go through all these penalties and pick a penalty which is the highest. The highest value happens to be 2 and only 1. Sometimes there may be a tie. If there is a tie, break the tie by randomly choosing anyone. Okay, so now I am going to pick W3, that is third column. So which cell in this third column? The cell having the least cost. The cell having the least cost, that least cost is 4, that is for the cell F1W3. Therefore, this cell is being selected for making decision now. So now, once you identify the cell, the remaining procedure is exactly same. So what is the corresponding supply? 40. What is the corresponding demand? 15. Therefore, have 15 here. So you can say 15 minus 15 is 0. 40 minus 15 is 25. and the demand of W3 is completely met. Therefore, it should not get anything from F2 or F3 or F4. Therefore, X230, X330, X43 is 0. Okay, one cycle is over. Again, I have to pick a cell. Again, before that, I have to calculate what is called as the penalty. Okay, now for the first row, 7, 6, 4 is skipped, 7, 6, 5, 9. That is 5 is least, 6 is next least, therefore the difference is 1. 8, 5, 7, 8. 8, 5, 7, 8. 5 and 7, the difference is 2. 6, 8, 6, 5. 5 and 6, it is 1. 5, 7, 8, 6. 5 and 6, it is 1. So for the first column, it is 1. For the second column, it is 1. Third column need not be done because all cells are decided cells. 5 and 6, it is 1. And 5 and 6 least, that is 1. Again, the second set of penalty calculation is over. So again, go through all the penalties and choose the highest penalty, and there is only one. It corresponds to the second row. In this second row, choose the least cost cell. That is nothing but this is the cell which is having the least cost. Choose this cell for making decision. So this is 30. This also is 30. Therefore, 30 minus 30 is 0. So I shall have 30 units. And 30 minus 30 is 0. The demand and supply are simultaneously exhausted. So therefore, this is 0. And this also is 0. And this also is 0. Simultaneously, the supply capabilities of F2 is exhausted. Therefore, all these values are zeros. So another cycle is over. Now again, what is the 7, 5 and 9? 7, 5, 9. The difference is 2. Second row is completely met. Therefore, there is no need of doing it. For the third row, it is 6, 6 and 5. 6, 6, 5. 5 and 6, it is 1. So for this, it is 5, 8, 6. 5, 8, 6. 5 and 6, it is 1. For the first column now, 7, 6, 5. This is 1. Second column is exhausted, completed. The third column, it is 5, 6, 8. 5, 6, 8, it is 1. So 9, 5 and 6, this also is 1. So therefore, third set of penalties are calculated. Go through all these penalties, and again 2 is highest and only 1. The first row is selected. Okay, in the first row, the least cost cell is this cell, and make decision for this. This is 25 and this is 20. So therefore have 20. 20 minus 20 is 0. 25 minus 20 is 5. This is 0. Therefore these cells also shall have their Xij values 0. Okay, or then again next one. So now 7 and 9, it is 2. The next second row is over. Third row, 6 and 5, this is 1. Next, 5 and 6, this also is 1. For the first column, it is 7, 6, 5, it is 1. Second column is over, third column is over. Fourth one also is over. So here 9, 5, 6. 9, 5, 6. This also is 1. The highest penalty is again 2, and that corresponds to the first row. And now the least cost cell is okay, F1, W1. Pick this cell for making decision. This is 5 and this is 30, and choose 5. So 5 minus 5 is 0. 30 minus 5 is 25. And therefore this is 0. Therefore F1 cannot send anything to W5. Okay. So another cycle is over. Now first row is completed. In third row there are only two cells, 6 and 5. The penalty is 1. 5 and 6 in the fourth row, again penalty is 1. For the first column, again it is 1. For the last row, it is 5 and 6, again it is 1. So therefore the penalty for all the rows and columns is same, and that is 1. Now you have to break the tie, okay, by choosing randomly any one. Suppose I choose F3, and therefore in this cell the least cost cell is this cell. So it is 20 and this is 5. Have 5. 5 minus 5 is 0. 20 minus 5 is 15. And the demand of W5 is met. Therefore this is 0. Now in third row and fourth row there is only one cell. Now we cannot calculate any penalty. Therefore it is obvious. So F3 has to supply 15 units to W1 because it cannot send to any other warehouse. Therefore it has to be 15. 15 minus 15 is 0. So 25 minus 15 is 10. So now this is the only cell. So I have 10 here. 10. 10 minus 10 0. 10 minus 10 is 0. Okay. So in this method, so again based on this calculation you can calculate what is the cost associated with this transportation plan, and accordingly you can say that. So this method, though it requires a little time, a little computation before choosing a cell for making decision, but this method in general gives a better starting solution. And if you start with this solution, most probably you require less number of iterations, and many times this itself will give you an optimum solution for some of the problems. And therefore it is always better to start get the starting feasible solution by Vogel's approximation method, and then you can start. So what is okay once the starting solution is ready, okay, then what exactly is to be done? So before I really wind up, okay, so all these cells now, okay, some of the cells have their Xij value greater than 0 and some of them have 0. For example, X11 in this, so it is 5 units. Okay, this cell, any cell whose Xij value is greater than 0, I call that cell as basic cell. So any cell whose Xij value is 0, I call that cell as non-basic cell. So accordingly, this cell F1W2, this cell is non-basic, this is basic, this is basic, this is non-basic. Okay, so this will help us to go further. Okay, please take care and stay in home. All the best. Thank you.